Hello friends, myself Jyotiraj Dixit. Today I will be giving a presentation on Apache Spark under the guidance of Dr. Vivek Srivastava sir. So we will be covering the topics like first we will see the introduction of it. Next we will move on to the features. Then we will jump on to the Spark architecture. After that we will see the working of it. And lastly we will see the ecosystem. So it was first initiated by Matai Zaharia in 2009, then was open sourced in 2010. Finally, Apache Foundation acquired it in 2013, and in 2014 it emerged as a top-level project. It is an open source cluster computing framework for a real-time data processing, and it is nearly 100 times faster than the Hadoop MapReduce architecture in memory, and in terms of disk, it is 10 times faster. The main feature of Apache Spark is the in-memory cluster computing, which increases the processing speed of the application. Also, it provides data parallelism and fault tolerance, means data is processed parallelly, and if a user makes mistakes, it handles it automatically. It is mainly designed for the wide range of workloads like the batch applications, iterative algorithms, interactive queries, and for the streaming purpose. Now let's move on to the features of Apache Spark. First, the speed. In terms of speed, it is nearly 100 times faster than the Hadoop MapReduce system. Second, powerful caching. It provides powerful caching and disk persistent capabilities. It can be deployed through Mesos, or we can use Hadoop via Yarn or the cluster manager of Apache Spark itself. For the real time, it provides real time computation and low latency because of the in memory computation. Fifth, the polyglot. It provides high level of APIs in Java, Scala, Python, and R. Sixth, the scalable means it is highly scalable. With the demand of the resources, it can manage itself. Now let's move on to the architecture of Apache Spark. It has a well-defined layered architecture, and all layers are loosely coupled. In clusters, they follow a master-slave architecture, means there is a single master and multiple slaves. It depends on two abstractions. First is the resilient distributed data set (RDD) and the directed acyclic graph (DAG). Resilient distributed dataset (RDD). It groups the data items that can be stored on the memory of the worker nodes. Where RDD stands for R means resilient. It means it deals with the fault tolerance and is capable of rebuilding data on failures. Means if the data is lost, we can rebuild the data from the other sets. Distributed means the data is distributed among the different multiple nodes or the workers data set. It means the collection of partition data with values. Means we need to collect the data after computation of all results. Data in the RDD is split into chunks with based on a key. They are highly resilient, means they can recover quickly if there is an issue. The same data chunks are replicated across the multiple executed nodes. Means the same data has been there on different nodes. Even if one executed node fails, another will still process the data and will output the data after some calculations. Now the directed acyclic graph (DAG). When an application code is submitted, the driver implicitly converts user code into transformation actions into a logical directed acyclic graphs. When a user code is submitted, it is then converted into a physical plans. Physical plans means into graph that how the execution will follow. It is a graph that performs sequence of computation on the data. Each node in the graph is an RDD partitions, means the node in the graph is an RDD partition, and the edge is the transformation on the top of the data. Here the edge also means the navigation from one node to the another. Now the architecture diagram. Here the master node is the driver program which contains a Spark context which interacts with the cluster manager, and the cluster manager deals with the different worker nodes. Hence it is a master slave architecture. Now the working of Spark architecture. Inside the driver program, the first thing we do is we create a Spark context. As we have already seen, there is a Spark context here. Now the driver program is the user code. Here is the driver program is the user code which is being entered by the user. Uh, we can say that a Spark context is a gateway like a database connection in different databases. It works with the cluster manager to manage the various jobs, and the driver programs in the Spark context takes care of the job execution within the cluster. Means they both deals with the job execution, that how the different jobs will be allocated to the worker nodes and which tasks they will perform. A job is a split in a job is split into multiple tasks which are distributed over the worker nodes. Anytime a RDD is created in Spark context, it can be distributed across various nodes. Means when an RDD is created, it is then split into different tasks. Then these tasks are distributed over the different worker nodes and can be cached there in, in the worker nodes memory. Worker nodes are the slave nodes whose job is to basically execute their task and return the result after being executing the task to the Spark context and the cluster manager. Basically, what's going on here is that the client first submits the application code and the driver immediately converts the user code into logical directed acyclic graph, that is the DAG, and performs the optimization such as the pipelining. When the DAG is converted into execution plans. And these execution plans are then converted into execution units, which are known as tasks. Then these tasks are bundled and being forwarded or transferred to the cluster manager. Then the cluster manager negotiates the resources and sends the task to the executor or the worker nodes. Then the worker nodes performs their operation or executes the task and returns these results to the cluster manager in the Spark context. And during the whole process, the driver program monitors the set of executors and schedules the future task. Means it monitors all the worker nodes of the Spark ecosystem. Spark comes packed with high-level libraries, including support of R, SQL, Python, Java, Scala, and the standard libraries increase the seamless integration in a complex workflow. Means using these different support to the language, we can integrate a lot of things like the machine learning library, GraphX, SQL plus data frames, and we can use these for the streaming services too, and it increases its capability. Spark ecosystem consists of various components. First is the Spark core. It deals with the core functionality and holds the task for scheduling and fault recovery. Next is the Spark SQL. It is built on the top of the Spark core and provides structured data. It allows query using SQL and supports JDBC and ODBC connection. And next is the streaming. It supports scalable and fault tolerance processes of streaming data. It uses Spark core for fast scheduling capability to perform streaming analytics. Now the MyLab means the machine learning library. It uses various machine learning algorithms, and it is 9 times faster than the disk-based implementation of these algorithms. GraphX. It is a library which is used to manipulate graphs, and it performs graph parallel computations. Now the Spark R, it is an R package which provides distributed data frame implementations. And it's also support different types of languages like the R, Scala, Python, and Java. That's all. Thank you.